All right, so now that we've got an idea of what the different equations look like for our parabolas, we're going to take a look at a couple examples. So let's start with this example one, and we have the equation y squared is equal to 12x. So I ask us here to analyze and graph the equation. So when I ask you to analyze it, I want you to find all of the different features. So I want us to figure out what direction it's opening. I want to find the vertex, the focus, the directrix line, and the 2 points on the lattice rectum, okay? So we're going to figure out all of those different features and then graph it out. So to start with, let's figure out the direction that it's opening. Okay, so notice here that we have a y squared. So whenever you have a y squared, that means it's either opening to the left or to the right. Then notice that this value right here is positive, which that's telling us then that it's opening to the right. Okay, so the first thing that we can determine here is that this equation opens right. And again, that's because it's a y squared and a positive coefficient of x. Okay. All right, so the next thing we need to figure out is what is our p-value. So if you remember our equations up here, okay, all of these are going to be in this format where you have your y squared is equal to 4p times your x. So this 4p is what we want to focus on right here. So we need to rewrite our equation so that it's in this format, 4 times some number. So I'm going to go ahead and rewrite my equation. So y squared is equal to 4 times something times x. So we basically just want to think 4 times what will give us 12, and of course 4 times 3 gives us 12. So that tells us that our p-value is equal to 3. Okay, the 4 is just a constant that's in all of these equations for a parabola. So you want to separate whatever number you were given into 4 times p. Okay. All right, next thing we want to figure out is the location of the vertex. Okay, so again, if you think back up to our equations, the vertex is always going to be at h and k. So in this case, because it's just a plane y and a plane x, there is no h and k. That means the vertex is just at the origin at 0, 0. Okay, we have our vertex right here at the origin. Okay. All right. Now, remember we said that our parabola is opening to the right, so that means our axis of symmetry is going to be the horizontal line that passes through the vertex. Okay, so that's going to be our axis of symmetry. Oops. Okay. All right. So then from the p-value and the location of the vertex, we can figure out the focus, the directrix line, and the lattice rectum. Okay, so first I'm going to work on the focus. Okay, all right, so remember p tells us the distance from the vertex to the focus. And the focus is always going to be in the same direction that the parabola is opening. So basically, if we start at our vertex, we're going to go 3 units to the right, and that's going to be our focus. So starting at the vertex, go 1, 2, 3 units right, and that gives us the focus. So that is at the point 3, 0. Okay. All right, then the directrix line. Okay, remember that directrix line is always going to be perpendicular to the axis of symmetry. So since our axis of symmetry is horizontal, the directrix line is going to be vertical. And again, the p-value tells us the distance from the vertex to the directrix line, but it's going to be in the opposite direction of the focus. So if we start at the vertex and go 3 units to the left now, so 1, 2, 3 units left, we can draw in our directrix line and perpendicular to the axis of symmetry. All right, so since that is a vertical line, that would be the equation x equals -3. Okay, remember the directrix is a line, so you have to write it as an equation. X equals for a vertical line, y equals for a horizontal line. All right, and then the last thing we want is the lattice rectum. So first we need to know the length of the lattice rectum, okay, which the length of the lattice rectum is always going to be equal to 4p. So basically, whatever number you started with in your equation before you separated it out as the 4 times p, so in this case, the 12, is the entire length of the lattice rectum. Now that tells us the total distance across the parabola at the focus. So if it's 12 units total, that means from the focus, we're going to go 6 units up and 6 units down to find the 2 points on the lattice rectum. Okay, so half of that total distance in either direction. Okay, so let's go ahead and count that out. So from the focus, I'm going to go 6 units up. That'll be the top point of the lattice rectum. And then from the focus, I'm going to go 6 units down. And that'll be the bottom point of the lattice rectum. Okay, so the 2 points on the lattice rectum then are 3, -6, and 3, +6. Okay, and then the last thing we need to do is just connect our points here. And that's our parabola. Okay. All right, so these are all the different pieces of a parabola that we're looking for. So again, when you're asked to analyze and graph, you want to figure out what direction is it opening, figure out your p-value. From the h and k, you can find your vertex, and then you can find the focus, the directrix line, and the points that make up the lattice rectum. Make sure you plot all of those different pieces and then graph your function. All right, let's go ahead and take a look at one more example here. So example 2, we're kind of working backwards. So we're given information and we want to take that information in order to figure out the equation of our graph, okay? All right, so let's see what it tells us. So it says find the equation of a parabola with a vertex at 0, 0. Okay, so we have our vertex at 0, 0. And I like to graph this out, even though the goal isn't to graph this function, it's just to find the equation of the function. It's still helpful to graph it so that we can sort of get a visual of what's happening, which will help us figure everything out a little bit easier, I think. Okay, so we have our vertex at 0, 0, and then it says we have a focus at 0, 4. So the focus is right here at 0, 4. Okay. All right, so based on that information, we can see that the focus is above the vertex. So I know that this has to be a parabola that's opening upwards because the focus is always going to be in the same direction that the parabola is opening. So the first thing we can easily tell here is that our parabola opens up. Okay, and from that, if you go back to your list of equations, if we have a parabola that's opening up, we know that this is going to be the format of our equation. X minus h quantity squared is equal to 4p times the quantity y minus k. So that is going to be the equation that we're trying to match this to. Okay, so we just need to figure out h and k, and we need to figure out p. Okay, well the h and k is the easy part because that's just the vertex which was given to us. So our vertex we were told was at 0, 0, which means our h and k are just 0 and 0. Now the p-value, remember p is the distance from the vertex to the focus. So if we just count this out, we can see we're going 1, 2, 3, 4 units up from the vertex to the focus. So our P is equal to 4. All right, so then just plug everything in. So we're going to have x minus 0 quantity squared is equal to 4 times 4 times the quantity y minus 0. Or if we simplify this, x squared is equal to 16y. So that is the equation of our parabola. Okay. All right, guys, I'm going to end this video here, but we're going to keep going with some more examples in the next video.